First of all, I'm thankful that I have been given a chance to talk to a professional audience. When I say professional audience, I mean professional in their trades after 1 year. The last professional presentation I gave was somewhere in February 2009 in Pakistan. I was really struggling to find out a subject which could be of every interest in the classroom, because there are few civil engineers and the majority is non-civil engineers. They are more tending toward more technological subjects or so. Here I have few figures or shapes which can brainstorm you toward a significant structure, and I think every one of you can easily configure a subject or topic of my presentation which is very general in understanding, very straightforward for the technical aspects, and which is a very major part of civil engineering. Whenever you think of a civil engineer, you think of bridges. Bridges, as I told you, are the most common structures or most significant structures on the earth. Bridges on the earth implies many things. Bridges implies the development in the world. Some bridges sites are the Romance sites. You can recall your memories from Last Minister Bridge, a poem from England. I'm forgetting the poet name, maybe Shakespeare. Some bridge sites are site of beauty. They inspire people. People want to visit those. But as a civil engineer and in general engineer, we have a concern with what are the technical aspects of the or engineering aspects of the bridges. We will try to figure out it today, and later in the very last part of the presentation, we will try to learn how can we design a simple kind of bridge which is called truss bridge. This slide demonstrates that how the bridges developed through the history. Bridge is not a new structure. People have been using it since BC, the old era, to the year 2000. They have been developed over the time by the material are utilized to build or construct a bridge, by the technology and by the engineering. Now we have very modern kind of bridges, but mainly these depend upon few basic concepts like the span, the requirement. What is the span we need to bridge, and what is the economical or feasible material available. These are the main basic kind of bridges: arch bridge, beam bridge, suspension bridge, and cable stayed and suspension bridge. Now the question rises that how bridges works. Every bridge is exposed to stresses like any structure in the world, but bridges are special when they tend to live load as well as dead load. And the live load in case of bridges is more critical for a designer. And then nearly every bridge is exposed to environment also. So these stresses, above all, cause or tend buckling into the structures. So the main structure of a bridge is basically the columns, the piers, and of course the foundation as well. Now coming to the types of the structure, describing the basic definition of the structures, the very first technology or very common technology which we used over the history is an arch technology. Arch is basically a natural structure which require no tension. There is no tension, normally there is no tension in the arch, so we utilize the compressive action of the member. The second type of the bridge is beam bridge, in which the surface of the bridge or the floor of the bridge is flat enough. Every flat surface tends to compression on the top and tension at the bottom fiber, so we need always reinforcing the bottom fiber. Third kind of bridge is suspension bridge. This is somehow modern technology. Suspension bridges are used or built basically where we have a longer spans, where there are more technologies involved, where there are more modern materials are involved. And a similar kind of bridge is once again cable stayed. It requires lesser material than compared to suspension bridges, but these are still very practical, and you can notice that these can be built over 500 to 3,000 feet long spans. The truss engineering, now coming to the last part of the presentation. The truss bridge is the very simplest kind of truss. Everyone who knows the basic arithmetic, trigonometry, basic knowledge of triangle, and basic Pythagoras theorem, he can design or he can initiate the design of a truss engine. Then the modulus of elasticity and strength of material kind of knowledge or sciences involved into the designing, because we are dealing with the materials and we need to know the strength of the material and the stresses. In the truss bridges, there is one basic kind, there are three main parameters. This is to be known. These are number of joints in a truss, which is basically a triangle, the number of members, and 3 is the 3 sides of the triangle. So we have a very simple formula to figure out whether this truss of the bridge is stable enough or not. So here is the formula, very simple. K is to be known. 2j minus r is the basic formula. In this case, there are 9 joints. 3 minus 2 times 9 minus 3 is 15, which is equal to m. And if once m is equal to k, the system is stable. Thank you very much. That's everything about the bridges in short time.